Yes, hello members. You are most welcome once again. As usual, Saddam Hussein, your mathematics teacher, is back. Thank you very much for supporting me. Thank you very much for viewing. Thank you very much for whatever you are doing. Now, for our learners, thank you for following our lessons. And always, I encourage that whenever you are there, don't forget to follow the lessons and don't forget to comment in case you have any challenge. Don't forget to give out your concerns because this is not for me, but it's for all of us all to benefit from. I want always to be very free and fair for everyone to achieve. Now, let us turn without wasting any time into our today's lesson, as we can see right here. We want to discuss something about distance, speed, and time. Distance, speed, and time. Remember, we had looked at the first part of it. Now today we are moving to another part. This is common in primary 6 and 7. I want you to be so much careful here. Now this is a bus. A bus traveling from Arua to Kampala. A bus traveling from Arua to Kampala. You see, I always move with slowly because I know what it means. All of you there want to learn at the same time. Whenever you're calculating a question of such kind, the first step is not telling that somebody is moving from Arua to Kampala. Make sure that you indicate each step you are going through that you have really understood. That's how you interpret, by the way. In most cases, people think it's just for fun, but interpretation begins. You now assume that this is the road. You are now putting the road on paper. The bus is traveling from Arua to Kampala. That's your destiny around there. A bus traveling from Arua to Kampala at a speed of 60 kilometers per hour. The speed that started with from here is 60 kilometers per hour. That's the speed it was traveling at. Unfortunately, it broke down after 1.5 hours. It broke down after 1.5 hours. That means the speed it was using was 60 kilometers per hour. Then it had so far traveled for 1.5 hours. So far, it had traveled for 1.5 hours. It broke down. So we don't know where it broke down from, but we can understand by the time it was breaking down what distance had they covered. The speed there that was using was 60 kilometers per hour. The time that so far used was 1.5 hours. Now, when we are calculating the distance, remember, last time we said distance is given by speed multiplied by time. So that is our distance there. So when you calculate the distance, we now have distance equals to our speed is 60 kilometers per hour. Per hour means divide by 1 hour times 1.5. You change it, you get it into improper fraction. 2 times 1 is 2 plus 1 is 3. That is 3 out of 2 hours. The hour goes up. I will tell you the reason why. Because in most cases, some of you don't mind of those units. You just do things and the units are left aside. Now from here, our distance equals to 60 kilometers out of 1 hour times 3 hours out of 2. This one must always go to the numerator so that this and this can cancel clearly to show that the hours have gone. We are calculating distance. When you don't show this kind of, in most cases, we always ignore. But I want to tell you that these are key areas. In mathematics, when you are marking, units are very key. Let the child understand. You as a child down there, the ones who are watching, the parents, and the teachers, let this child clearly show you how these hours are cancelling to become distance. People just write anything, they calculate without any unit, and they come and pick from nowhere and say, this is the answer. No, let us have some order. So this is 1 by 2, you have 3, 0. These are kilometers. So 30 kilometers multiplied by 3 is 90 kilometers. This is now distance that he had covered. That means the distance so far he had covered here was a total of 90 kilometers. When you have that kind of partition, it becomes okay. Before the bus had got that problem, or before it broke down, it had covered a distance of 90 kilometers. Remember, it was traveling from Arua to Kampala at a speed of 60 kilometers per hour and broke down after 1.5 hours. This is the 1.5 hours that used, and it was traveling at 60 kilometers per hour. The repair took them 30 minutes. Remember, when they were repairing, no distance was covered. They were constant here, but time was going, of course. Time was going. They used 30 minutes. Time was going. Time can never be stopped, but distance can be 0 and speed can also be 0 kilometers per hour. Why? Because you can not stop time. Time will always be constant. Now, after realizing that he had used 1.5 hours and the repair took him 30 minutes, the question now is, at what speed must the bus travel? At what speed must the bus travel in order to use a total of 3.5 hours? If the distance from Arua to Kampala is 270 kilometers, at what speed must that bus now travel? Remember, someone has set a target that I need to reach Kampala after 3.5 hours exactly. But so far I have used 1.5 and the repair has taken me 30 minutes. But now what should I do in order to make sure that I reach Kampala in the targeted 3.5 hours? What advice can you give that driver? What speed must he use, or what speed must the bus travel at to make sure that he covers the distance of 270 as a total? The total from Arua to Kampala is 270. So far, okay, the distance from there to there is 270 kilometers. What has he covered so far? We all know that after calculating that, what he has covered so far is 270 kilometers minus, what he has left, what is left with, he has so far covered 90 kilometers. Now 270 kilometers minus 90 kilometers is 180 kilometers. That's now the distance he's remaining with. This is the distance left. He's supposed to cover it within the remaining time. What time is remaining? Remember, he traveled for 1.5 hours, and again he rested, which we are calling it resting, but he was doing repair for 30 minutes. 30 minutes is the same as a half an hour. So 1.5 that he had already traveled plus 30 minutes, which is a half an hour. This gives you how many hours? 2 hours. So it's left with 2 hours against 180 kilometers. You can see how simple the question is. The words are very many for nothing. The story is too much, but it is very simple if it moves by the steps that we are trying to identify here. You organize your work well. Mine looks congested here, but organize your work well. I told you from the beginning that you only indicate the movement, that somebody is moving from Arua to Kampala. Yes, that is that. Then interpret step by step. He was traveling at a speed of 60 kilometers per hour. Yes, and broke down after 1.5 hours. What do you do there? He was moving at a speed of 60 kilometers per hour and broke down after 1.5 hours. So you're supposed to know before he had broken down how many kilometers had he covered. That's when you now say speed times time. But I told you that check these units without bias and make sure that you show someone that the hours are leaving and the kilometers are remaining. That is in distance now. So the time he had moved was 1.5 hours, then the distance he had covered was 90 kilometers after 1.5 hours. He rested for 30 minutes. The 30 minutes are equivalent to half an hour. So that is a half plus 1.5, those are 2 hours. I remember the distance from Arua to Kampala, an estimated distance is 270 kilometers. Now 270 kilometers is the total, but he has so far traveled 90. So we subtract 90 that he has already moved from the 180 kilometers. Now the time he has so far moved is 2 hours. What time is he left with? Remember, he was supposed to use only 3.5 hours. 3.5 hours minus 2 hours, which gives you 1.5 hours. So this is the time left, and this is the distance left. The time left and the distance left. So what advice do you give him if he wants to cover the remaining distance to shoot a target of 3.5 hours? That means now he's left with 180 kilometers against 1.5 hours. What is the speed there? It is simple now. We only need to calculate the speed. Remember, speed is given by distance divided by time. So our distance that is left with 180 kilometers divided by time, which is 1.5. You change it to improper. 2 times this is 2 plus 1, which is 3 out of 2. These are hours. Now, this is 180 kilometers. You get the reciprocal multiplied by 2 out of 3. The hours will come down. Remember, it is for the numerator, it will come down. Such that if you have here a denominator of 1, you divide by 3, 1 by 3, 6, here, 0. So you have 60 kilometers times 2. 60 kilometers times 2 out of 1 hour. This one gives you 60 times 2 is 120 kilometers out of 1 hour. So we now say 120 kilometers per hour. 120 kilometers per hour. So that is the speed he's supposed to use to travel. The speed he's supposed to use is 120 kilometers per hour in order to cover that distance of 270 in 3.5 hours. Remember that resting time is included. Don't leave out the resting time, because his target when he left Arua was to travel direct to Kampala using 3.5 hours and at a speed of 60 kilometers per hour. But unfortunately, since he got a problem, the bus broke down and the repair took them 30 minutes, which is a half an hour. We will therefore have the distance so far covered before breaking down was 1.5 hours time. It was a speed of 60 kilometers per hour. So to get the distance there, you multiply speed times time to give you 90 kilometers for that distance. Then to get the total distance left, you are supposed to subtract the distance from Arua to Kampala, which is 270 minus 90, to give you 180 kilometers. Then the 180 kilometers is the distance left. Then the time so far used was 1.5 plus a half, which is 2 hours. Now 2 hours subtracted from 3.5 gives you 1.5. Now this is the time you're supposed to struggle to use to cover a distance of 180 kilometers. These are simple questions I told you. You don't need even a lot of issues here. Just interpreting, just explaining for a child very well without any problem makes this child very comfortable. Otherwise, I want to appreciate you so much for attending. May the Almighty God bless you and keep you always giving you whatever you need that you feel is making you comfortable should be given to you. I thank you very much, my fans, everyone, everywhere. I do love you so much, and thank you for supporting me. Let us work together to change this motive of mathematics. People say mathematics is very difficult. We want to change it and say no, the subject is too simple. God bless you.